So, little background. So, Greg Fisher, I am the founder CEO of Berkeley Sourcing Group. We do manufacturing for startups in China. So, we were kind of started this 10 years ago, kind of before it became popular or really even feasible in many ways to compete as a startup company with a physical product. And it's been, we've learned a lot in that time. One of the few, I think, that really has a long-standing experience and relationship with a lot of these startups. So could definitely talk to the experience of the market and how things have changed. If you guys have questions about that later. But fundamentally, what we do is this turnkey manufacturing in China. These are some of our products. We have a team of 25 on the ground in Shenzhen. We have 2 factories in the Jiangxi province in the middle of China. We primarily take over from design for manufacturing through to qualified product delivered to the warehouse. We're much more hands-on at the factory level. We work with startup companies that really ideally in many ways need to work with small factories. Managing that size is part of the strategy that's important, because if you are trying to work with a large manufacturer, they'll give you a lot of lip service, but when it comes down to solving problems and really having the energy and excitement to help you develop your product, they're not that interested typically. In that time, we've worked with over 800 startups, at least through quoting and evaluation phase. We have worked with over 200 Chinese factories. And I want to just kind of bring up the reason why you guys are kind of here, probably to solve some of the stories. Everyone's heard the horror stories of this stuff. A couple of my favorites. Guy says, "Hey, I've got this boot I want you guys to make." And he sends over a boot to the Chinese factory, happens to have a nail in it. Factory makes 10,000 of them with a nail in it. So they kind of did their job a little bit, and there was a little miscommunication there. One that I had personal experience with, just had been onboarded as a quality manager at a professional automotive tool company. Our upper management wanted to do a quick turnaround on a charger and a battery for a power drill. They said, hey, we wanted to charge in 1 hour, not 8 hours, make it happen. Factory made that happen, and it exploded. And some of these exploded on the charger, one of them even in a drill in somebody's hand. So these are kind of describes a spectrum of things that I'm going to cover today, and how did this happen? How can you solve these problems? In some ways, there's definitely a process. There's a clear path to get this stuff done. But there's all kinds of technologies. I'm going to divide things really into 2 categories. From what I've seen, there are a lot of startups. There's the strategy of manufacturing, and there's the execution of manufacturing. And what a lot of startups really don't have is strategy, because even if you come from a big company and you understand manufacturing, there were 20, 30, 40, 50 people on that team that each kind of had their role that implemented the strategy kind of unwittingly in many ways. The processes were developed, the relationships were developed, and so coming out of that environment now where you really need to know all of that as a very small team is really a challenge, and one that not many startup companies have. And then once you have that strategy, how do you execute? What are the mechanics? What are the details? So we're going to break that up. What are the fundamentals of a manufacturing strategy? So fundamentally, they're all about finding the right partners. You're not, as a small team, you're not going to know enough to get a lot of what needs to get done yourself. So you're going to have to rely on people to help you get that done. You're going to need to understand your responsibilities and your manufacturer's responsibilities. Where's the line? Who does what? Very important. You need to learn how to communicate, how to listen, how to be humble and accept that you won't know everything, because there's a lot to know. And finally, I wanted to make a special kind of discussion about the testing aspect of manufacturing, because it's actually a really big part of how this stuff works and how it gets done effectively. So who are the right partners? The right partners really should be transparent. You'll have a lot of questions, and these questions are going to be process related. They're going to be technical related. You're going to have to dig into those details and figure out what it is that makes the product work, what is it safe. So you need to understand that process. You need to understand that process about your product and its details. So your partner, the only way you're going to learn that is if people share that information with you. You want a partner who's willing to do that and who's really willing to bring you up to speed with what is happening with your product and your process. To be responsive, I still find this today to be one of the greatest ways just to vet business partners in general is, do you get that email back in an hour, in a day, in a week? You know, this startup world, it moves very fast. The nice thing about testing partners in this way is you can use this with anybody, right? You don't need to be very knowledgeable or experienced or anything else. Did they send that email back quickly? You get that, you have that answer very quickly. So. Experience, obviously, you want to work with people who have done this before, but I'd say also, particularly with startups, because startups, what we're doing here right now is really unique. There are, if you look at the history of the world, the number of startups that were able to compete with big business in taking physical products to market is tiny. There's very little infrastructure, there's very little support, and that infrastructure and how that is going to work works in a very different way than the big business that has developed the infrastructure that exists to make that happen. So you have to, in some ways you're going to cut some corners, in some ways you're going to do things very process oriented. When do you do that? How do you make those decisions? You need to really kind of think outside the box in a lot of the systems that you're using. Finally, you have to be able to execute at the factory, right? It's many of the problems that can come up. If you find them in your product, in your warehouse, there is nothing you can do. It's too late. You've lost the time of shipping on the water. You've lost your customer's interest because you can't deliver the product on time. It's just way too late. So you really have to be able to execute at some level, at least in a verification level, directly at the factory, either yourself or with somebody that you trust that can make sure that you catch and fix those problems before they get on the boat. So one of the things that comes up a lot that we've experienced is the definition of responsibility. Right? Who is responsible for what? You get into the heat of the product. You've sent the factory or your partner 500 emails. They've sent you 500 emails. There's 20 people involved. You've sent some specs. You've sent some other stuff. You think you've done a great job, letting people know what need to be made. And then all of a sudden a problem comes up. Right? Whose fault is it? Who needs to take responsibility? Who needs to cover those costs? If you're not approaching this the right way, that can be very confusing. But it's actually very, very simple. And you need to keep it simple. And you need to communicate that with your factories, that these are your expectations and this is the way that it works. If you're working with China directly, communicating this clearly is important and will help you establish a much better relationship. At the end of the day, whatever happens, this is kind of the fundamentally understood responsibility, and there's a really important reason for that. So your job as the startup is to define exactly what needs to be made, to leave really no question, no room for error, including all the tolerances. Nothing is perfect, right? So if you send a design without a tolerance, and they make it slightly, they're not going to make it 0.00000 infinitely to that dimension, right? So what is acceptable? You need to be upfront and very clear about that. And then you also want to, as much as possible, provide them the information that they need to test to those specs and make sure that there are machines capable to test that quantifiably and that those will be used in that testing process. The reason this is so important is because when you're sending that information for quote, that's the only time the factory has to really give you a quote that they can stick up for, right? If you now say, hey, I've got these specs and you don't send tolerances, and they send you a quote, and then a few weeks later you say, oh, and it's going to have to meet these tolerances. Well, the factory's already committed to you to make a certain kind of product, and now you've just changed what you're asking them to do. And typically how it works, particularly in China, is that they know that you're choosing suppliers based on price. So they're going to give you the best price they can, which means they're going to use the loosest requirements and tolerances they can. So you want to make sure that you've accounted for that and given them that direction. The other reason that actually this is really important, it's a little bit more subjective, is that just as you're sizing up the factory is sizing you up as a partner and someone to work with. And startups have a bad rap. They are not often very successful. It's very difficult to take a product to market. So factories are not super keen to work with you to start. I mean, of course, they want the business, and they'll say lots of nice things when you meet and you're talking. But they go back and they're thinking, oh, geez, another startup. I don't know if I want to do this. I have to figure out all these problems for these guys, and we have to, make new innovative products that have never been made before, and maybe the technology doesn't even exist. And these designs they gave me, I don't really know what to make of them. So the other part of defining this well is that you're giving the factory the confidence that you're professional, that you know what you're doing, and you're making their job a whole lot easier, right? If they know exactly what they need to make, they can immediately know, do they have the capabilities, right? Do they have the machines? Do they have the engineering power? Do they understand the process? Is it well defined? And, that can take the really hard part of their job and cut down that work by 80-90%, if they know how the process is going to go. It really simplifies their work. It makes them much more eager to work with you, and it makes the quote much more reasonable and probably something that they can follow through. So communication is another interesting, subtle thing that we've I've seen so many projects go kind of one way or the other, depending on the client that we're working with. I see some big head nodding back there. Where it's really hard to define, and it's really a little bit hard to even talk about. But I can give you some examples of what is bad communication. Is like sending like 20 emails in a day with like one sentence about this and one sentence about that, and please change this, and and a lot of maybe non-productive emails, like give me an update on this little thing or that little thing. And what you're doing is you're creating a lot of work for your partner with very little benefit. One thing, try to include all the details, right? When you're making a product, if you're going to make it right, you want to over-communicate in some ways. The way you try to make that effective is by being as organized and concise as you can. So do include all the information, but try to really keep it all organized. Try to keep it in one email as much as possible. Try to keep it sent in an organized way, and we'll go into the mechanics of that as well. Obviously, use simple English. This is part of habit training. If you're having these conversations or these emails, just try to be always paying attention to what you're saying. Written is usually better than oral English. People, in China, everyone in China has this program in their computer where if you mouse over a word, it will automatically translate that English word into Chinese. So they can do that on the computer. They can't do that on the phone. It doesn't work real time like that. And just typically, there's a lot more practice in written than oral English. We really like Skype because, if we're doing conversations, because we can capture things real time in chat. So while you're talking on the phone, you can also be writing things just for confirmation in the chat window if there's anything unclear or if there's a word, that the team might not understand. It's really easy to look up, and you kind of have the advantages of both at the same time. I throw this in here because it really is an important part of the strategy. Through my experience, one of the things that I look for in a client is clients who can listen. And the reason, besides just being nicer to work with, it is actually just proven to me that those clients are usually much more successful because it is really hard to do what we're trying to do, and you need to learn a lot. And it's really hard to learn a lot if you're talking all the time and you're not listening and you're not trying to absorb that information. So do try to understand that there's going to be a lot of things that you don't know well, that you don't need to know well, that you shouldn't have to know well. You should find the right partners who know those things at a much better level than you do, and use them, right? Use them by listening, by learning from them, and getting the answers from them and working with them effectively. So that's kind of the strategy stuff, just the general how you should approach this. And I'll move more into the execution here to talk about the mechanics more specifically of how you can do that. So the first thing you want to do is paint a clear picture, right? You need to tell your manufacturer what it is you're going to make exactly. The tools that we call this the engineering package. It's got various names. And then you want to be on the ground to make sure that things are going well, and you want to test thoroughly to make sure you find them before they get on the boat. So this is a clear picture. This is a fuzzy picture. This is the same picture, and I feel like this is the picture we start with a lot of times. You're not going to make this product if you're giving this information, all right? There's obviously a huge gap, and somewhere between here and there, you're going to have to fill in all of those details. If you're not doing that when you've got the quoted price, then you're not working with a real quoted price. If you're not doing that when you get the quote, you might not have a manufacturable product, right? There's a lot of things to go from here to there, and until you get to that clear picture, and you have really defined what it is that you're going to make, then you really don't know. You're not going to be given the feedback to know if it's feasible, what the cost is, all of these other details. So how do you do that? Here's your toolbox. So first, a product requirements doc. This is a document that basically is going to explain the expectations of your product in the market. All right, what are all the kind of intangibles, and how do you see the product in your customers' hands? How are your customers going to use it? What are these use cases? They cover some of the more intangible sides of things. What is it going to look like? How durable do you expect it to be? How safe does it have to be? What certifications? How is the user going to interact with the product? What's the demographic, right? What are the intangibles of how it should look, feel, and act? Include potential problems, right? Help your partners understand what are the things that you've learned that could really pop up as issues. Inside and outside is kind of a big one that defines a lot of things that will need to go into your product. And if there's just any funny little thing about your product that might be a little bit different than what people are used to. We're all here as startups making innovative products. What that means is they're different, they're unique, they've never been done before. they're typically an iteration or so away from a common product. And so the partners that you're going to be working with, the people that are going to be helping you, are going to use their knowledge of how to make that other product. And they're going to bring a lot to the table in that regard. But you're going to need to help them with anything that is different and out of the ordinary. And the first way you do that is giving them a really good understanding of what your goals are, what your market goals are. So bill of materials, a couple key things. One is that it is going to identify all of your components, right? If you have a little screw here, a little gasket there, these things can be missed, and they can cause big problems as you go forward. It also gives the complete picture, again, is filling out all these details to your manufacturer to understand everything and how it's going to go together. The devil is in the details. It's amazing what a little thing can do if it's missing, and so you want to make sure that you're explaining to the manufacturer everything that's going to be in your product. If you can, use part numbers. Part numbers can give a tremendous amount of information, very clearly and effectively, and it allows for this opportunity for feedback from your suppliers. Technical files, fundamentally in today's world, I'd say by far the most prominent are 2D, 3D, and Gerber files. If you're making any kind of, injection molding or CNC, you're going to need the 3D file to cut the tool. So you'll need to send that over. There's some other advantages. You can do lots of physics testing, FMEA, if you guys are familiar with that, and stress testing, mold flow analysis. Lots of detailed science can go into that 3D drawing. You can calculate the cost of the weight and the cost of the material, the amount of material and the runners and so forth. So it really provides a tremendous amount of information. 2D files are kind of, I think, a little bit undervalued today. They're a great way to explain the tolerances to really look clearly at some critical dimensions. And they're usually a place where people put on the surface requirements. But having that 2D, a lot of people think, I sent the 3D, there's all of the information, but it's still a little bit hard to see. You take some slices and you say, hey, this is the 2D of this particular area, and you can help clarify some things there. Don't forget about surface finishes. It's a critical part of every product. It often gets overlooked and can often cause big problems down the road. So component specification, this is not necessary a lot of the time, but if you have something more complex, a motor, a subassembly, something with different moving parts in one piece, it can be really helpful to basically go through this process for that particular component, so that the manufacturer knows what it is. Again, part numbers go a long, long way. If you're using something off the shelf or something similar to something off the shelf, make sure you include that part number. That can be Googled. You can get a ton of information just out of that one little part number. Some of this, one of the things you would want to include here is more of the surface finish. And here's just some examples. If you're using colors, make sure you use Pantone numbers, right? A color is red is like 5,000 different colors, so it doesn't really tell your manufacturer what you're trying to make very well. Make sure you clearly define that with your Pantone number. And finally, a prototype. We say a picture's worth 1,000 words, a prototype is worth 1,000 pictures. Even though all of the information can be in all of these files that I've spoken about, getting a prototype in your hands and seeing how it works and understanding it for anybody, no matter how good of an engineer, is a really powerful thing. You can immediately see some issues that you might not have seen before. You can see interfaces. You can understand maybe some of the difficulties of turning buttons on and off or so forth. So definitely do try to provide your prototype if you have one, or make one to communicate that. It's also a great way to communicate expectation levels of quality, right? Hey, we're going to make it to this minimum level and nothing less. So. When you do that, make sure that you include what you like, what you don't like, what you want to change, what you must change, versus what you would like to change. And if you clearly document that, that really helps a bunch. Quality control. So work with your manufacturer in the beginning to define how you're going to inspect the product. When you do that, look at the tools that are going to be used for inspection. You want things to be quantitative. It's a very tough job to go from a set of specifications to figure out how that's going to be tested. It takes a lot of work. The factory has a lot of the information and the tools that you probably don't know of. But by working together, you have the market knowledge of what your product needs to do and what is really important. So you communicating that to the factory and working with them on these details and figuring out how to quantifiably measure to make sure that it's within the tolerance you've specified is really critical. I cannot emphasize enough, you've got to catch these problems before they get on the boat. Besides just the cost of remaking the product, which 95% of the time you're going to do, because it won't be reworkable, that's the least of your worries at that point, because you've made promises to customers, they're not getting product. It's often a fatal catastrophe if you get stuck in that position. So make sure it happens, be there yourself, send a third party, make sure that somebody else is going to watch on your behalf to make sure that those problems don't get on the boat. A couple things about inspection. There's 3 processes. There's incoming, there's in process, and there's outgoing. If you are working with a third party, the factory should have all of these in place, but basically incoming is all the materials and components coming in to the factory where it's going to be all put together. Those should be QC'd and inspected. There's in process, the process the components are going through to being assembled and putting into a working unit. There's outgoing. Our team gets really into the details here. We're going to work with the factory and figure out, is that a real component that got put on that board, right? And so forth. So you do need to be careful about bait and switch, and then this is where you would solve those problems. A couple things about testing is that it's only good as the tools that you're using for the test. It's only valid in the environment and at the time of doing the test. And how I think about it now really is kind of 2 different ways. There's things that you can inspect and say, okay, yes, this is a good product. There's a durability test, right? These seats, if you just inspected these seats, you could find all of them good coming off the factory floor. But if there was an extra 10% of regrind plastic material over 6 months of people wobbling back and forth and going up and down and sitting down, they all break, right? This is something that's very hard to test just coming off the line. So you have to use kind of a special sort of thinking to think about, okay, we're going to test this today, but how is this going to be in 6 months, a year? Particularly if you're looking outside or in harsher environments, or the interactions with humans, right? That's usually where it's kind of break down over time. Safety is kind of a part of that durability sort of issue. It's something that is hard to quantify and measure at the time of the inspection. So you want to put a lot of extra thought into that. You can develop tests for this stuff, right? You can make a machine that sits on this chair and moves it around 100,000 times. But it's hard. So you want to really take special consideration. Things go swimmingly, really, really well. This is kind of what you're looking at typically. So if after you send all of the information and it's almost perfect, you're going to be sending that engineering package, you're going to work on a pre-production prototype. You want to make a pre-production prototype to confirm with your factory, one, it's feasible, they understand everything, and you're going to communicate with that prototype to make sure it's the product that's going to be delivered. You guys are going to test that and approve that. That takes a little bit of time. You're going to open tooling with all the modifications and everything else. Typically is 45 to 60 days. I mean, we can often do this in 30 days. We have a pretty quick turnaround in that, but to be on the safe side, this is a more normal situation. We find a first production run between usually 30 to 60 days, depending on quantities, difficulty, the innovation of the product, so forth. So you're looking, roughly around 45 days. Nothing ever goes right the first time in production, so throw in an extra 15 days in there to tweak things as they come up in the line. You've got 30 days on the water, a few days to receive at your warehouse and inspect. So things go really, really well. You're looking at 7 months typically. Things often don't go really, really well, so be prepared for that. A couple of things working with China, particularly, obviously, language is a big barrier. There's a huge cultural focus on price over quality, which means you need to have the opposite approach, right? You want to be focused on quality, 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 and not price. And in the end of the day, you'll end up with a much cheaper product by getting the right quality. The other problem is that a lot of the times there's not much understanding of the customer expectations, is that the workers in the factory floor can't relate to your customer sitting in an ergonomic chair. They've never sat in an ergonomic chair before. They don't know what are the important parts or why is that important to the market. So you need to really help them understand what are those critical aspects, because like that boot with the nail in it, maybe that's what's in style these days. You just don't know. So. The other thing is they'll typically build to your acceptance level. So this is kind of a tricky game that is played. Hey, I give you this product that didn't meet 10 of your requirements, but it's the best we can do, and we're doing it fast, and we're a great partner, and this is the best anybody can do. And sorry, no, that is not okay. We don't accept that. We told you in the beginning, this is how it is. Fix it. They'll go back and fix 5 of those things and send it again, and they'll keep trying this because they want to make it cheaper, they want to make it easier, right? And so this is where setting that expectation in the beginning, hey, we're getting a quote on these exact specifications, this is exactly what you're going to make. Every single one, 100% of the time, is going to be within this acceptable level. You can solve a lot of problems that way, but make sure that they understand that you will only accept what you've specified and then do your job to make sure that those specifications are reasonable. So China and IP. I'm running out of time. I'll be happy to answer questions about this. I know this is a hot topic. So our experience, we've sent designs out to 800 plus factories. To my knowledge, not a single factory that we've worked with has stolen, copied, used our designs, and sold them outside of China. First of all, basically give up on China, unless you have a China plan. Whether it's your partners or a million other people, someone's going to copy it. As soon as you put it on Indiegogo, Kickstarter, or whatever, they're going to copy. They're going to have access to it. So the key thing is what you're really looking at is who are the competitors to get your product to market, right? Anybody can copy anything now. They can reverse engineer an iPhone, right, in a matter of weeks. And the reason, the technologies are out there, the hard part for these China partners is getting to market with your idea. And if you have an innovative new idea, that's tough, right? You're going to have enough difficult times yourself trying to educate your market, find your customer, build your brand, do all this stuff. Some guy who makes, injection molded parts in the middle of China who doesn't speak English has a real uphill battle to make that happen. What we have found is a lot of our products have been knocked off by Taiwanese factories and by American companies. Who then made it in China, but they are much more real threats in many ways. So your IP strategy really needs to be complete. It's not just about China. It needs to be, you need to have your patents in the right place where you're going to go. You need to have the right brand strategy to continue to develop, to be ahead of the market. and so forth. If you just use the Alibaba approach and you throw your designs out to 100 factories, some factory may think it's a great idea and start selling it in China pretty much immediately. That may catch on and may cause you problems. But overall, if you're fairly selective and you're working with the right people, and you can sign agreements all day long, that's not really going to change too much. As soon as you try to execute that, their factory disappears, they're gone, they're opened up a block down the street under a different name. It's so easy to do in China, it's ridiculous. It's not going to protect you too much. So have a bigger strategy that really addresses your global market and needs.